So we're going to be taking a look at the higher level Leaving Cert 2022 paper, question 10 and paper 1. So a student is asked to memorise a long list of digits and then write down the list sometime later. The proportion p of the digits recalled correctly after t hours can be modelled by the function pt is equal to 0.82 minus 0.12 times the natural log of t plus 1 for some value of t strictly greater than or equal to 0 or less than or equal to 12, where t is a real number. Find the proportion of digits recalled correctly after 3 hours according to the model. Give your answer correct to 2 decimal places. Gives us a time. T is a function of time. So then if we find p of 3, that's going to be equal to 0.82 minus 0.12 times the natural log of t, in this case 3, plus 1, so the natural log of 4. And if we were to compute that, we'd end up with the value 0.65, rounded to 2 decimal places. Part B. After how many hours would exactly 55% of the digits be recalled according to this model? Give your answer correct to 2 decimal places. So before we were plugging in a value of time, now we're looking for the time. So in here we have 0.55 is equal to 0.82, subtracting 0.12 times the natural log of t plus 1. So we're looking for t here. I want to first of all figure out this part in a positive sense. So I want to move that to the left hand side. I'm going to move the 0.55 to the right hand side. So I'm going to get 0.12 times the natural log of t plus 1 is equal to 0.82 minus 0.55 gives you 0.27. Now I'm going to divide both sides by 0.12. I have the natural log of t plus 1 is equal to 0.27 divided by 0.12. And if we were to calculate that, it would be 2.25. Now, how do I get this t outside of it? Well, if you remember your rules of logs, I can raise both of these. I can raise e to the power of both of these, which will bring the locked logarithm inside here all the way down. So when we raise e to the natural log of e, that cancels it out. So the answer for this one would give you t plus 1. Whereas on the other side, we just have e to the 2.25. And now I just need to subtract 1 from both sides. E to the 2.25, subtract 1. Oop. So I get t is equal to 8.49 hours. And again, just to clarify, this method here crops up the whole time when we're dealing with logs. Although we're not dealing with calculus just yet, like the rest of this video is, it's important to remember your logs and just know them for the Leaving Cert, because if you don't remember this, it could be a nightmare and you'd only get down to here, see if you're getting half marks or even if that for this question. So you just be dropping marks where remembering this one fact or knowing where to find in your tables, which we go over the tables. We can find our section all about logarithms right here. And if we look at on the top right hand corner, we're going to see this identity here, or this rule right here. So if we have some number a and we put a to the power of the logarithm of a to some value x, that equals to x. So in the example we were just given, we were trying to figure out how to get this t plus 1 out of the natural logarithm. Well, what is ln of any number? Well, that's log to the base e. So by raising the natural log of t plus 1 on top of e, or raising e to the ln of t plus 1, it just meant that whatever was inside the brackets of the natural logarithm came out. So this is equal to t plus 1. And that's how I was able to take that out and just find t as itself. Now, find the value of p prime of 1. So first of all, we have to remember that p of t was equal to 0.82 minus 0.12 times the natural log of t plus 1. So now we just need to differentiate this, and then whatever the derivative of that is, we can sub in 1, and that's how we figure out this. So p prime of t, first of all, the 0.82 is a constant, so that disappears. Then we have minus 0.12 times the natural logarithm of t plus 1. The minus 0.12 stays there. And then at the bottom, we just have the natural log of t plus 1, which just goes to 1 over t plus 1. Now what we want to do is we want to find the value where p prime and we sub in 1. Well, that's going to be negative 0.12 all over 1 plus 1, which is negative 0.06. P prime of t is always negative for values between 0 and 12, where t is a real number. What does this tell you about the proportion of digits recalled correctly after t hours? Well, what is p of t, or p prime of t? It's going to be the rate of change of pt. In other words, it's going to be equal to the slope. What happens when the slope is always negative? Well, then we're going to have that the number, or the proportion of digits recalled correctly after t hours is always going to be decreasing. I.e., the further we move along between 0 and 12, the less digits you're going to remember. So part D, use calculus to show that the graph y is equal to pt has no points of inflection. Points of inflection, we're going to have the derivative of the derivative, so p double prime of t, well, we had negative 0.12 all over t plus 1. If we use the quotient rule for this, u and v, we're going to have u being equal to minus 0.12, so du is equal to 0, and then we have v is equal to t plus 1, so then we have dv just equal to 1. Plug this back into the quotient rule. We're going to have v du, so t plus 1 times 0 minus 0.12 times 1. Double negative here, this left hand side goes to 0, so we just have 0.12, and then this is all going to be divided by v squared. So if we look at v, we have t plus 1 squared, so this is all going to be over t plus 1 squared. What does this mean? This means because for this to equal 0, we're going to have to multiply both sides by t plus 1 squared. So in other words, what we're actually going to have is 0.12 all over t plus 1 squared equal to 0. If I multiply both sides by t plus 1 squared, what I'm actually going to get is that 0.12 equals 0, which it doesn't. So because this doesn't make sense and we can't have 0.12 equaling 0, we can therefore say that y is equal to p of t has no point of inflection. Again, we have, if we learn a skill and then don't practice it, how well we can do it usually decreases over time. For example, if you learn to play the guitar and then don't play the guitar for a number of months, you will probably not be as good at playing the guitar the first time you try it again. This effect can be modelled by the following equation, where a is equal to b times t plus 1 to the c, where a is a measure of how well the skill can be done at a certain time, b is a measure of how well the skill can be done t months later without practicing, and c is a constant, and a, b, c and d are real numbers. Part 1. Write c in terms of log 10a, log 10b and log 10 of t plus 1. So what we want to be doing is we want to be taking all of these and putting them into log form. So we have log 10a is equal to the log of 10b, which is multiplied by t plus 1 to the c. Remember our rules of logs. We have log of 10a. This is going to be equal to the log of 10b plus the log of 10 t plus 1 to the c. We want to have this all in terms of c, so what I'm going to do is I'm going to take that log of 10b over to the other side. So here we have log 10 t plus 1 to the c, and equal that to the log of 10b subtracting log of 10a. Other way around, sorry. The log of 10a subtract the log of 10b. With logs, we can bring this power all the way around to the front. So what I'm going to have is c multiplied by the log of 10 t plus 1, equaling that to the right hand side again. and then divide both sides by the log of 10 t plus 1, so that it's all just in terms of c. So therefore c is going to be the log of 10a minus the log of 10b, and this whole thing gets divided by the log of 10t plus 1. Part 2. A student got 80% on a guitar exam. After 2 years of not playing the guitar, the student got 47% on the same exam. Use this to find the value of C in terms of the model. So, first of all, this model works in terms of months. So 2 years is the same as 24 months. Now we just plug everything back in. So we're looking for C, and that's going to be equal to the log of 10. When we let 80 go into the exam, or into the equation, we get that. We subtract away the log of 10, 47. And this whole thing gets divided by the log of 10. T is 24 months plus 1. So if you stick all of that into your calculator, what you're going to get is that this whole thing is equal to 0.165. And this is all correct to 3 decimal places. So any questions on that, just let me know. I'll get back to you as soon as I possibly can.